For years, tech leaders promised a future where AI would replace developers entirely. Headlines claimed coding would become fully automated, costs would drop, and companies could ship products faster than ever. Investors bought the dream, executives repeated it, and startups raced to fire engineers. But behind the hype, cracks were already forming, cracks most people didn't notice until systems began to fail. Why companies believed it? Large language models showed impressive demos, writing functions in seconds, generating entire apps, fixing bugs instantly. To non-technical leaders, this looked like magic. If AI could write code, why keep expensive developers? The assumption was simple: software development is typing, and AI types faster. That assumption would soon prove dangerously wrong. Code is not just code. Software development is not about producing lines of code. It's about architecture, trade-offs, edge cases, performance, security, and long-term maintenance. AI models generate patterns, not understanding. They don't grasp business goals, legal constraints, or system history. When companies treated coding like content generation, they misunderstood what developers actually do. Early adoption chaos. Some startups replaced entire engineering teams with AI-first workflows. At first, velocity looked impressive. Features shipped quickly, demos worked, and leadership celebrated savings. But under the surface, systems became fragile. Bugs multiplied. Documentation drifted. No one truly understood how the codebase worked anymore, including the AI generating it. The productivity myth. Studies later showed that AI sometimes slowed down experienced developers. Engineers spend more time reviewing, correcting, and debugging AI-generated code than writing it themselves. The illusion of speed disappeared when production bugs emerged. What looked like efficiency was actually deferred cost. Security failures. Security researchers found that a large percentage of AI-generated code contains vulnerabilities. SQL injections, authentication flaws, unsafe defaults, mistakes that junior developers are trained to avoid. AI models reproduce insecure patterns from training data and cannot reason about threat models. This turned production systems into attack surfaces. The ownership problem. When a human writes bad code, responsibility is clear. When AI generates broken logic, accountability becomes blurry. Teams struggled to debug issues because no one fully understood the generated code. Root cause analysis became guesswork. Systems failed, but there was no engineer who truly owned them. Skill atrophy. As teams leaned harder on AI, developers stopped practicing fundamentals. Architecture skills weakened. Debugging intuition faded. Junior engineers learned to prompt instead of reason. Over time, organizations lost deep expertise. And when AI failed, there was no one left who could fix the problem properly. Technical debt explosion. AI favors generic solutions. It repeats patterns. It does not optimize for long-term maintainability. This led to massive technical debt, duplicated logic, bloated abstractions, and fragile dependencies. Companies that fired developers saved money briefly, then paid far more rewriting entire systems. The context gap. AI does not understand business nuance. It doesn't know why a decision was made years ago, why a workaround exists, or why certain constraints matter. Developers carry this context in their heads. When AI replaced humans, that invisible knowledge vanished, and systems began behaving unpredictably. Debugging reality. Debugging is where AI struggles most. It cannot reason about emergent behavior across systems. It cannot form hypotheses and test them creatively. Developers debug by intuition, experience, and pattern recognition across failures. AI can suggest fixes, but it cannot truly investigate. False confidence. One of the most dangerous traits of AI is confidence. It produces plausible code even when it's wrong. This misleads teams into trusting outputs that silently fail. Unlike humans, AI does not know when it doesn't know. This creates invisible failures that surface only in production. Case study: Rush Systems. Several AI-first products collapsed after launch. Payment bugs, data corruption, scaling failures. In postmortems, teams discovered AI had introduced subtle logic errors across critical paths. Rebuilding required rehiring senior engineers, often at higher cost than before. Culture damage, engineering culture suffered. Mentorship disappeared. Code reviews lost meaning. Juniors had no seniors to learn from. AI could not teach judgment, ethics, or craftsmanship. Teams became dependent on tools instead of people, weakening long-term resilience. Legal and compliance risks. AI does not understand regulations. It can generate code that violates data protection laws, licensing terms, or industry standards. Companies discovered legal exposure after deploying AI-generated systems that failed compliance audits. Fixing this required human oversight that had already been removed. The costs lie. Executives expected AI to reduce costs. Instead, expenses shifted. More QA. More incidents. More downtime. More rewrites. What was saved on salaries was lost to outages and reputation damage. The economics no longer made sense. What AI is actually good at: AI excels at scaffolding, boilerplate, documentation drafts, and simple refactors. Used correctly, it boosts productivity. Used as a replacement, it destabilizes systems. The problem was never AI. It was misuse driven by unrealistic expectations. Human judgment matters. Developers make trade-offs. They balance speed versus safety, elegance versus pragmatism. AI cannot weigh consequences. It cannot feel risk. Human judgment is the missing ingredient that keeps systems stable under pressure. The rehiring wave. By 2026, many companies quietly rehired developers. Titles changed, narratives softened, but the reality was clear: AI-only development failed. Teams returned to hybrid models, pairing AI with experienced engineers instead of replacing them. Why the narrative persisted: the myth survived because it benefited investors, tool vendors, and executives chasing short-term gains. Saying AI replaces developers sounded revolutionary. Saying AI assists developers sounded boring, but true. Developer testimonies. Across forums and conferences, developers reported the same pattern: AI helped, but only when humans stayed in control. Teams that resisted replacement narratives outperformed those that embraced them blindly. Systems are socio-technical. Software is not just machines. It's people, processes, incentives, and communication. Removing humans breaks the system. AI cannot participate in accountability, ethics, or responsibility, the pillars of reliable engineering. The AI agent confusion. Agentic AI worsened the problem. Autonomous code-writing agents created feedback loops of errors. Without humans supervising decisions, small mistakes compounded rapidly across systems. Why humans scale better? Humans adapt. They learn from failure. They build intuition. AI repeats patterns. Scaling engineering requires people who understand consequences, not just outputs. The future model. The winning teams use AI as a collaborator, not a replacement. Humans design, decide, and review. AI accelerates execution. This balance delivers speed without sacrificing reliability. What this means for jobs: developers are not disappearing. Their role is evolving. The value shifts from typing code to designing systems, guiding AI, and owning outcomes. This makes good developers more valuable, not less. The real lesson: technology fails when humans abdicate responsibility. AI magnifies decisions, but cannot make them wisely. Replacing developers removed the very safeguards that made software trustworthy. History repeats. Every automation wave promised replacement. Each one ended in augmentation. AI is no different. The mistake was believing intelligence equals judgment. Where we go next: the future belongs to teams that respect human expertise and use AI deliberately. Not as a shortcut. Not as a replacement. But as a tool. AI did not fail. The idea of replacing developers failed. Software still needs humans to think, care, and take responsibility. The lesson is clear: when we remove people from the loop, systems don't become smarter, they become fragile.